Hello, this is the genuinely approachable Sudoku for the 4th of February 2024. It is minus 40 degrees by Philip Newman. So it is a clone thermal Sudoku. So let's look at the rules. Normal Sudoku rules apply, so place the digits 1 to 9 every row, every column, and every 3x3 box. Thermal, digits along thermometers must strictly increase from bulb to tip. So you have some thermals here. These must form an increasing sequence of digits, which can, basically do anything at once as long as every digit is greater than the previous one. That is valid. Next, clones. Cages of the same shape and letter are clones. So this is cage A, this is cage A. They are clones and must contain the same digits in the same relative positions. So for example, if this is a 3, 4, 5, 6, 7, 8, 1, 3, 4, something like this, then this cage must be exactly the same as that cage. It must be a clone essentially, which is where the name comes from. So yeah, with that, I guess we can begin solving. I guess an interesting fact about the title of this puzzle is that negative 40 degrees is the degree at which Fahrenheit and Celsius agree. So minus 40 degrees Fahrenheit is equal to minus 40 degrees Celsius, which is, I guess, where the clone comes into play. And then thermals for temperature, obviously. Sorry. Okay, actually, I start solving. So we have very few numbers here, but we do have some long thermometers. These are all 6 digits long. And if I were to good lift it, I can place 4 digits in each. Yeah, I can place 4 digits in each thing here. And actually that does help us because we know those digits have to be identical to those digits. So that digit is that digit. And since they must be the same, they actually have to both be 4 because that's the only digit they can both be. So that's both 4. This 4 now forces everything up on this side. This 4 does force everything down on this side. And by clone, those have to be 5 and 6. This 2 puts a 2 over there, and this 8 puts an 8 over here. This thermal... well, those digits are those digits. And actually that digit is that digit. That digit is over there, so it doesn't do anything. This one is over here, again doesn't do anything. Okay. Well, 9 in this box has to be one of those cells, because 9 sees those cells, and these cells are not at the ends of the thermometer, so it can't be 9. A 9 here would imply something bigger than 9, which isn't possible. Okay, let's see. We know that... No, I don't think we know much. I'll say that these digits are those digits. So those two are the same, which might say something, but it doesn't really. It doesn't really say anything. Okay. 3, 1, 2. Okay, I'm not very good at spotting these clone things. So help me out of here. Actually, no, yeah. 1 actually does the same thing. In this box, where can 1 go? 1 can't be there. 1 can't be there and there either, because those are not the ends. Those are not the bulb of the thermometer. So this has to be 1, 9. Sorry, that has to be 1, 9. 4 is one of those cells, and 6 is one of those cells. 4 here, I think this forces this to be 1, 3. Yeah, because this has to be less than 4. And would therefore be the... if this is a 6, then this would have to be 7, 9. So I intuitively think this is 4 and this is 6, but I can't do that until I prove so. So that's intuitively, I think that's 4 and 6 there. This is like 5 or something. But we can't prove that again. Okay, so what now? I feel like it's more of these bigger thermometers, or these thermometers over here. Or maybe I could good live this again. This is 1, 2, 3, 4, or 5. It can't be 5. This is 2, 3, 4, 5. Can't be 6. This is 4, 5, 6, 7. But can't be 7. This is 4, 5, 6, 7, 8. But it can't be 8. This is 5, 6, 7, 8, or 9. But it can't be 8. So I guess, okay, because this cell is over there, that's 4, 5, 6, or 7. But this can't be 4. So that can't be 4. This just can't be 5. Which means what? This one will be there, so that's 6, 7, or 9. This is 6, 7, or 9, but it can't be 7, so this isn't 7. 1, 2, 3, 4. This is over here. So that's 1, 2, or 4. Actually, no. This 2 sees that, so that's not 2. And because this is not 3 either, this is not 3. So this is actually 1 or 4. This one is 2, 3, 4, or 5. It can't be 4, so that can't be 4. It can't be 2, so this can't be 2 either. So this now can't be 3. Yeah, this can't be 3. Could it be 6? No, because this now can't be 6. No, sorry. This could be 6. This is 5, right? No, everything still seems to work out. No, 5 here sees that cell, so that's not 5. That's not 5. And therefore, this now can't be 6. So that's just 9. That's 9. Actually, this 6 sees that, so that's also just 7, 7. Yeah, alright. I think I did this very messily. That's 3. So that's 3. Meaning this has to be 1. So that's 1. Yeah, sorry, I did this very messily, but if you checked all my working, it would hopefully make some sense. These are now 4, 5, and 6. We know 4 can't be there, 6 can't be there. This is now less than 7, although that could be a lot of things. And we still don't know. Alright. 3 is fine. Actually, it's quite interesting to know that 2 cannot appear in the clone anywhere. 2 can't be in those cells. So those cells cannot be 2. 2 can't be there. I guess that still gives us a lot of options. 2 here. No. I think 1 is one of those cells, right? Right, because in here 1 is not in those cells. That cell can't be 1 because this cell can't be 1. This cell can't be 1 because it's not in the bottom of the thermal. So 1 is one of those cells. So 1 is one of those cells. Maybe we can do the same with the 9. Here. Where 9 can't be there. Can't be there because this can't be 9. So 9 is one of those cells. Which means 9 is one of those cells. This cell is actually that cell. So that can't be 9 either. 9 can't be there. But 9 could be anywhere in those cells. Just like, well, what could this be? I guess. Because that cell is here, right? Yeah. So what could this be? This is not 1. It's not 2. It's not 3, 4, 5. It can't be 8 or 9. So it's either 6 or 7, I think. Can we do anything to resolve whether it's 6 or 7? No idea. What about that then? Again, that can't be. It can't be 1. It can't be 2. Because of that 2. It could be 3. It could be 4. It can't be 5. It can't be 6. It can't be 7, can't be 8, and can't be 9, so it has to be 3 or 4, which means this has to be 1, 2, and this has to be 2, 3, right? Following the pattern here. Yeah, but now this can't be 3, so that's just 2, meaning that has to be 1. And then similarly here, because it is 6, 7, this has to be 7, 8, that has to be 8, 9. This one can't be 7, so that's 8, 9. This 9 resolves that 1, 9 pair here. Those cells have to be 7 and 3 to complete the row. And then stuff happens. Those cells are 3, 4, 5, and 8. 8 can't be there. 8 can't be there, so 8 in this row must go there. Same here, I think. The 2 can't be there, 2 can't be there, so 2 has to go there. This is also 3 or 4, because it's a clone of this. So this is 3, 4, or 5. Can't be 4, so in fact 4 has to go here. So now that's 4. This is 6, 7, or 5. 5, 6, or 7. Can't be 6, so 6 goes there, and therefore there. 3, 5 means that's now 7. That is now 3. This digit is over here, so that's 5 or 7. This digit is over here, so that's 3 or 5. Oh, and the 5s here and here allow us to prove that those are both 7s, those are both 3s, those are both 5s. Yeah, that checks out. I was a bit confused for a while. Those are 4, 6, 8. This can't be 8, that can't be 6. This can't be 4. Okay, very nice. Chocolate teapot here. This has to be 2, 4, and 6. This is 2, 4. That can't be 6. Another chocolate teapot, but I guess we've come to expect that already. Can we do it? Can we do the exact same thing here? This is 2, 7, 9. But this can't be 7 or 9, so that's 2. This is a 7, 9 pair. And hopefully the same we can do here. This is 1, 1, 3, 8. That can't be 1 or 3, so that's 8. 1 or 3 goes there. Can we look at those digits then? Those are 2, 4, 6. No, 2, 4, 7, 9. This can't be 2. That can't be 4. This can't be 2 either. No, nothing. Wow. Okay. Super helpful here. I think we can do basically the same thing on that side. This is what? 1, 6, 8, 3. 1, 3, 6, 8. This can't be 8. That can't be 8. This can't be 6. Yada yada yada. Okay. I think it's just regular Sudoku, right? Yeah, at this point it's regular Sudoku because all the clues are now taken care of. So it should just be regular Sudoku from this point. 5 is in one of those cells. And then something something. 6. No. 8. 8 is in one of those cells. 8 here. No. 8 is one of those cells. 8 is one of those cells. No, and then 2 is one of those cells, right? Yeah. 4s? Yeah, 4 is in one of those cells, I guess. But it doesn't teach us much. And we can say the same for 6. 6 is in one of those cells. 9? Ah, 9s. 9s has to be there, which means 4 goes there. And then same here, 1 has to be here, 6 has to be there. This is now 2, 5, 8. This can't be 2, so 2 goes there, 8 goes there, 5 goes there. This is also 2, 5, 8. Those can't be 8, so 8 goes there. 2 goes there, 5 goes there. Very symmetrical, so that's cool. That's not 8, so 8 can only be here. 2 can only be there, which resolves this entire thing. This 8 resolves this entire thing as well. Cool. 4 means that's no longer 4, so 4 goes there. This, I think, yeah, 6 can't be there, so this has to be 6. We're almost done. This is 7, 8, and 9. This can be 7 or 8, so that's 9. This is 7 or 8. And in fact, that's not 5, so 5 goes there. I think here we can do the same thing. 5 goes here. This is 7 or 8. This 8 resolves that. 7, 8, 7 resolves this 7, 9 pair, which resolves this 7, 9 pair. This has to be... I mean, that's just 1. So this is 2 and 3. 2 can't be there, so that's 3. 2, 3 resolves this. Oh, 3 in the corner. 1, 3. And then the middle, this has to be 5. As I said, that's 4. That is 6. Solving the puzzle in 14 minutes and 9 seconds. Oh wow, tougher than usual, tougher than usual. Well, I hope you enjoyed that puzzle. Yeah. I'll see you next time. Bye bye.